you're looking at a triangle that could be labeled triangle ABC. And we've marked the three angles of the triangle, angles 1, angle 2, and angle 3. And we call those three angles the interior angles of the triangle. If we extend one of these sides of the triangle, we get a new angle, angle 4. Angle 4 is called an exterior angle of the triangle. If we extend all the sides of the triangle in both directions, we now get angles 4, 5, 6, 7, 8, and 9, and they're all called exterior angles of the triangle. There are three other angles not marked with numbers. They happen to have the labels for each vertex in the interior of the other three angles. While these three angles are all equal to the interior angles of the triangle because they're vertical angles, these three angles are neither interior nor exterior angles of the triangle. Every triangle has 3 interior angles and 6 exterior angles. Our 3 interior angles are labeled with black numbers, and our 6 exterior angles are labeled with blue numbers. All 6 exterior angles of an acute triangle are obtuse because, of course, they form a linear pair. And in an acute triangle, the 3 interior angles are all acute. So to make the linear pair, which of course is a pair of supplementary angles, the exterior angles all have to be obtuse. An obtuse triangle has 4 exterior angles that are obtuse, marked in blue, and 2 exterior angles that are acute, marked in red. And of course, the 2 exterior angles that are acute are exterior to the obtuse angle of the obtuse triangle, which in this case is angle 2. A right triangle has 4 exterior angles that are obtuse, marked in blue, and 2 exterior angles that are right, marked in red. And once again, the exterior angles associated with the right angle of the triangle, the one labeled angle 1, those are the 2 exterior angles that are right angles. And now Theorem 30. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Well, first, let's define remote interior angles. We'll start with exterior angles 4 and 5. They're adjacent to angle 3. So the remote interior angles are angles 1 and 2. Now let's look at the exterior angles 6 and 7. They're adjacent to angle 2 in the triangle. So the remote interior angles relative to angles 6 and 7 are interior angles 1 and 3. And finally, let's look at exterior angles 8 and 9. They're adjacent to angle 1, so the remote interior angles relative to angles 8 and 9 are interior angles 2 and 3. And we will prove one at a time, so we're going to start with exterior angle BCD, and we're going to prove that it's greater than interior angle ABC. And it's kind of obvious because you can see it's an acute triangle, so all 3 interior angles are acute. You can see that our exterior angle is obtuse, so it has to be greater than the acute angle. But we're going to prove it for sure. It's a little bit complicated, but we're going to get it done. And we're going to start by finding the midpoint of side BC and labeling that midpoint M. And then we'll draw the ray A towards M, and we can do that because, of course, 2 points determine a line, in this case, of course, a ray. And then we're going to mark the point P on that ray so that AM is congruent to MP, so that M is also the midpoint of the segment AP. And then we'll mark those 2 segments as congruent. And then we're going to draw CP because we can. 2 points determine a line, in this case a segment. And we're going to mark some other congruent pairs of parts. We already know that M is the midpoint of BC, so we mark that MB is congruent to MC, and we mark the 2 blue angles that have vertex M. We mark them in blue because, of course, they're vertical angles. And that gives us a pair of triangles congruent by side, angle, side. And from that, we can note that we have a pair of angles congruent by corresponding parts. And one of those angles is the interior angle that we're trying to prove is smaller than the exterior angle. And you'll notice that the angle that is congruent to the interior angle, angle MCP, has to be smaller than angle BCD by angle addition. And therefore, we've proven that the exterior angle BCD is greater than the remote interior angle ABC by substitution. If we draw segment BP, we can go on to prove that the exterior angles at vertex B have a greater measures than angle ACB, and we can continue repeating the proof by locating the midpoints of the other two sides so that we can prove it for the rest of the angles. In this lesson, we introduced interior and exterior angles of triangles. And Theorem 30, the exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle.